Welcome to the first lesson of the Bonding Structure and Properties of Matter topic. In this topic, the key questions are 1. What are the different types of chemical bonds? 2. What is ionic bonding? 3. What are the characteristics of ionic compounds? Key terms that you need to be familiar with: chemical bonds, ionic bonds, ionic compounds. In today's lesson, we will talk about the chemical bonds and about ionic bonding and compounds in particular. Atoms can join in different ways to form compounds. One way is when an electron pair is shared between two atoms. This is called covalent bond. And another one is when an electron is donated from one atom to another one, ionic bond. Ionic bond is based on electrostatic attraction between positive and negative ions. Metallic bond is similar, but in this case the attraction happens between multiple electrons and positive metal ions. These are the three types of chemical bonds that in the next lessons we will cover in detail. We know that the majority of the elements are metals. Groups 1, 2 and 3 elements and the middle block elements are all metals. A common characteristic of metals is that they can more or less easily lose electrons from their outer electron shells. Task. Now please pause the video and think about the reason why metals can lose electrons easily. Hint. Think about the electronic structure. Extension. How does it contribute to the current topic, ionic bonding? Metals are located towards the left side of the periodic table, which means that they have 1, 2 or 3 electrons on their outermost electron shells, valence electrons. In order to stabilize the electronic structure, the actual atom needs to have 8 electrons in its outer shell. This is called noble gas structure. The elements on the left side of the periodic table can stabilize by losing electrons and obtaining the electronic structure of the previous noble gas. For example, lithium, Na, has 11 electrons. It has an electronic structure of 2, 8, 1. 2 electrons on the first shell, 8 on the second, and 1 on the third. In order to make it a 2-8 structure, it needs to lose the only electron from the third shell. Magnesium, Mg, has 12 electrons, and it goes through a similar process, but it needs to lose 2 electrons from the third shell. Those elements whose atoms can lose their electrons easily from the outermost shell go through ionization. Ionization can either involve a formation of positive ions by losing electrons or the formation of negative ions by gaining electrons. They all form positive ions. The lost electrons cannot just move around freely. They will attach to other atoms that need those extra electrons to stabilize their electronic structure. For example, chlorine, Cl, has 17 electrons with the configuration of 2, 8, 7. Therefore, it needs only 1 extra electron to make a neon-like 288 structure. The image above clearly explains how ionic bonds are formed in the case of sodium chloride. Na loses 1 electron and forms an Na positive ion, and the electron attaches to Cl and it forms a Cl negative ion. These 2 ions will therefore have opposite charges. This means that there will be an electrostatic attraction between them. This attraction is very strong and is able to keep ions in an organized lattice structure. See image below. The electrostatic attraction can happen between complex ions too. One example is sodium sulfate, Na2SO4. In this case, sulfate ions, SO4 to the power 2-, have 2- charge, therefore it is compensated by twice more Na+ ions. Other complex ions are nitrate, phosphate, carbonate, hydrogen carbonate, hydroxide, and an example for a positive complex ion is ammonium. Task. Now please pause the video and think about the relationship between the position of an actual atom and the charge of the ion it can form. Hint. Again, think about the electronic structure. Extension. What physical properties does ionic bonding have? The location of the atom determines how many electrons it can lose or gain when it forms an ion. For example, LiNaK can lose 1, BeMgCa can lose 2, Al can lose 3. On the other hand, FClBr can gain 1, O and S can gain 2, N and P can gain 3, just to name a few. Therefore, there is a clear rule for it. The group number, N, tells how many electrons can be lost if N is less than 4. If the group number is more than 4, then the number of gained electrons are determined by 8 minus N. Ionic bonding is very strong due to the strong electrostatic attraction between the positive and negative ions. This means that the lattice structure they make is very stable and can hardly be destroyed. This is the reason why ionic crystals have very high melting and boiling points. As the ions are located in fixed positions, there are no freely moving charged particles. Therefore, they do not conduct electricity.